going to be looking at rule 4 of the exact differential equation, right? So for rule 4, which is a very interesting rule, when you have x to the power of m, y to the power of n, then you have your ay dx plus bx dy plus x to the power of m prime, we're going to call it m prime, right? Y to the power of n prime, then we have a prime y dy, then we have plus b prime, let me shift this, b prime of x dy is equal to 0. When your equation can be expressed in this form, then it is rule 4, or let me say case 4, right? When it can be expressed in this form, it is case 4, and when it's expressed in this form, your integrating factor is going to be x to the power of h, y to the power of k. And you might be wondering, where is h and k coming from? It's coming from this formula here, where you have m plus h plus 1 over a is equal to n plus k plus 1 over b, and m prime plus h plus 1 over a prime is equal to n prime plus h plus k, plus k plus 1 over b prime. So all these formulas are very, very important, because you are going to use it to find your h and k, which will be used to find your integrating factor. Then after you find your integrating factor, it's all roses from there, because you just multiply the original equation and then you apply the method we use for the base form to solve. Right, so let us look at a question. Right, so here we have y cube minus 2x square y, then we have the x, then we have plus 2xy squared minus x cube, then we have dy is equal to 0. So we have this question. So now for this question, now we want to express it in the form above, right? Because currently it is not in the form above. So now how can we express this question in the form above? So what we're going to do quickly is that we can factorize y out in this part of the question, right? We can factorize y. Let me see if I got the question correctly. Alright, I did. So now, but we cannot just go ahead and factorize y, right? Because what we want to do is that we want to express it in this form that we have above. We have ay dx, but bx dy. So that means there's going to be a dx and a dy in the same bracket. And to do that, we have to first expand this bracket, right? So we're going to have y cubed dx minus 2x square y dx, then plus 2xy square dy minus minus x cube dy is equal to 0. So now we have already expressed expanded the bracket, and we have the equation like this now. So we're going to look to merge them together. So we're going to take one dx and one dy together, right? So the way we know which one we are going to group together is through the coefficients, right? So now if you look at y, this first y that we have here, we have y cubed. Now if we pair it with this dy, we can factorize y square out, which is something that we want, right? But if we pair it with x cube, we cannot factorize y out, we cannot factorize x out, so that's not going to work for us, right? And the same thing for the x. If we take minus 2x square and you pair it with x cube, you can factorize x square out, which is something that you want, right? You want to factorize a coefficient, or you want to factorize a variable x or y that has a power that is from 2 and above, right? So now we're going to group them. So I'm going to have y cube dx, then we're going to have plus 2xy squared dy, then we're going to have plus negative 2x squared y dx negative x cube dy is equal to 0, right? So we have this. Now we have already expressed it in the form above, right, where we have ay dx, right, plus bx dy, right? But we are not done, right, because we still have to get x raised to the power of m and y to the power of n. So now what we're going to do now, from this first one, we're going to factorize y square out. Alright, so now we're going to factorize y square out. So we're going to have y squared in brackets y dx plus 2x dy, right? Then we're going to have plus, we're going to factorize x squared out, so we're going to have x squared, then we're going to have in brackets minus 2y dx minus x dy is equal to 0. So we have this now, and we can see that it looks a lot like the form above, right? What we can do is because now we have x to the power of m, we don't have x here, so we're going to have x to the power of 0, we're going to add it. So now this tells us x to the power of 0 is 1. We just want it to look so much like that form so that it is very easy for us to solve. So now that we have it like this, all that is left for us to do is just write out our parameters, right? So our m is going to be equal to 0, our n is going to be equal to 2, our a is going to be equal to 1, right? If you look at it, we have ay, so that means a is the coefficient of y, which is 1 in this question. Then our b will be equal to 2. So then we're going to have our n prime, our n prime is going to be equal to 2, our n prime is going to be equal to 0, our a prime is going to be equal to negative 2, and our b prime goes to negative 1. Right, so now that we have all this sorted, then we're going to apply our formula, and then we're going to solve, right? We're going to apply these formulas that we have here, and the reason why we're applying it so that we can get our m, our h and k. So we're going to have m plus h plus 1, our m is 0, so that will give us h plus 1, right? And then over a, which is 1, and this is going to be equal to n plus k plus 1. Our n is 2, so it's going to be k plus 3 over b, which is 2. So we're going to have 2h plus 2 is equal to k plus 3, right? So equals to k plus 3. And now we are going to make k solid of the relation. So we are going to have k is equal to 2h minus 1. And then we are going to use the second formula, that's this one here, so that we can get the second equation and solve simultaneously or by substitution. Alright, so now we have m prime, and m prime is 2, so we're going to have 2, that's h plus 3 over a prime, which is negative 2, right? Negative 2, and then it's going to be equal to n prime, which is 0, so we're going to have k plus 1 over negative 1, and then we're going to have negative h negative 3 is equal to negative 2k minus 2. All right, and then we're going to just substitute our values and solve. So we are going to have our values. Remember, k is equal to 2h minus 1, so we're going to have negative h negative 3 is equal to negative 2. We have 2h minus 1, then we have negative 2, right? So we have minus h minus 3 is equal to negative 4h plus 2, negative 2. So this will cancel out this, right? So this one will come to this side. So we're going to have negative h plus 4h, which is going to give us 3h, and this minus 3 will come to this side. So we're going to have 3, and our h is equals to 1. Now our k is equals to 2h minus 1. So this 2 times 1 minus 1, and our k is equal to 1 as well. So now don't forget, our integrating factor is equal to x to the power of h, y to the power of k. Our integrating factor for this question is going to be x to the power of 1, y to the power of 1. So our integrating factor for this question is going to be equal to x, y. So very, very simple. So this is how we get it. So what you have to do is first make it to be in the form, right? Whenever you see the question, you see you have x, y, you have your question, and then you can factorize. So what you do is first you expand the bracket. After expanding the bracket, then you regroup them. Then after regrouping them, what you're going to do is you factorize your x and your y. Then after factorizing, you make it to be in the form as you have the x to the power of m, y to the power of n, a y dx plus bx dy plus x to the power of m prime, y to the power of m prime in bracket a prime y dy plus b prime x dy equal to 0. Once you have it in that form, then you would now get your parameters, your m, your n, your a, your b, your m prime, n prime, a prime, and b prime, and then you apply your formula m plus h plus 1 over a is equals to n plus k plus 1 over b, and m prime plus h plus 1 over a prime is equals to n prime plus k plus 1 over b prime, and then you solve simultaneously the equations that you get. Then you find your h and k, then you apply your formula for integrating factor of x to the power of h and y to the power of k. And after you are done with that, you're going to be multiplying the original equation, right? You're going to multiply the original equation by your integrating factor. So let me rub this off so that we can finish up our solution. So after multiplying by your integrating factor, what is left for you is just to apply your base form method of solving. So we have xy multiplied by y cube minus 2x square y dx, right? Plus this is the original equation, so we have 2xy squared minus x cubed dy is equal to 0. So we're going to have multiplied by xy here. Alright, so we're going to have xy to the power of 4 negative 2x cubed y squared dx. Then we're going to have plus 2x squared y cubed minus x to the power of 4y dy is equal to 0. And then we're going to integrate with m dx plus integral of n dy is equal to c, right? Remember, for n you are integrating only the value of n that has only y as a variable. So we have the integral of xy to the power of 4 dx minus the integral of 2x cubed y squared dx. Now for n we don't have any variable, any value of y that has only y as its variable. So we have plus integral of 0 is equals to c, and here we're going to have x squared y to the power of 4 over 2 minus, here we're going to have 2x to the power of 4y squared over 4. Then we have equal to c, and what we can do here is that 2 we cancel here, 2 we cancel remaining 2, so we have x squared y to the power of 4 over 2 minus x to the power of 4y squared over 2, and then we can multiply through by 2 to eliminate 2 as the denominator. So we have x squared y to the power of 4 minus x to the power of 4y squared is equal to 2c, which is the same as c. And what we can do here now is to factorize x squared y squared, and then we have y squared minus x squared is equal to c, and this is going to be your final answer. This brings us to the end of this video.